Thank you so much. So the title of the research project here, the Zukunftskolleg, is explaining and predicting large-scale violence and civil conflicts. And I didn't realize at the time that this would also be the title of my presentation. So when I put together the slides, I thought about explanation and prediction in more general terms and how to sort of convey to an interdisciplinary audience what we as political scientists understand when we use these terms. So this is what I'm going to talk about first, and then I'll zoom into Civil War research. And then I have like a couple of examples of the research project that I've been able to conduct here at the Zukunftskolleg that I will sort of briefly go over. But if you have any questions at any time, just interrupt me, and I'm of course also happy to sort of skip over a couple of slides at the end in favor of a good discussion that we might get going. So when a member of the Zukunftskolleg says they're explaining or predicting something, they might mean different things depending on the discipline. The natural sciences, particularly physics, have set the standards rather higher, I'd say. So for example, physicists know a lot about the force that made the apple fall on Newton's head. Of course, I don't know if any apple ever fell on Newton's head, but it's just too good a story to, sort of not tell. And the story goes that Newton sits on his apple tree, the apple falls on his head, and he suddenly realizes that the force that made the apple fall is the same force that keeps Jupiter in orbit around the sun, and the moon in orbit around the Earth, and stuff like that. And that, of course, is a fascinating insight all by itself. But more fascinating even is that physicists can use this knowledge for predictions. So I can walk up to a physicist and say, look, I want to throw an apple with this mass on the planet Earth, with that mass, and this is going to be the angle, and this is going to be the velocity that I'm going to throw this with. And they will be able to, and that's the fascinating part, use the general law and just plug in the numbers of the examples that I've just given them to arrive at a prediction. So the general law is just essentially the application to a specific case, or the prediction is just the application of the general law to the specific case. And that's really amazing. And by and large, I think we as social scientists can't do that. Of course, I'm not the official cultural ambassador of social science. That's just my own personal heretic opinion. But why would social science be lagging behind? And one reason for that might be that social science is a really young branch of science. If you're in history, philosophy, mathematics, physics, or medicine, you have essentially research programs under your belt that go back to ancient times. So history, in terms of talking about what people have done before you and the generations before you, might be even older than that, but we still know of historical recordings from Roman times, for example, today. If you're in chemistry or biology, and by extension, or alchemy, that means you have a research program that has been going on since medieval times, and social science is an entirely modern affair. So that means we somehow have, or let me specify this a little bit. I think by convention, the first political scientist that we like to refer back to today is Machiavelli. So that 16th century thinker who was in the fortunate position to see what was going on in terms of the strife between the Italian city-states at the time, the internal strife and the wars between them. And he was able to sort of derive general lessons about authority and how to stay in power and how to use that power and to extend it. Now that is still, to some extent, social philosophy. You just look at a bunch of observations and you derive your one governing idea of how power works in general. And it's not so much about testing observable implications of your theories. And if we zoom in even more and talk about something like quantitative political science, or in my case, quantitative conflict research, the first person who's ever done that is Lewis Richardson, who worked in the first half of the 20th century. So we only have, in comparison to these other disciplines, a century of cumulative research and so on. And that means we also had fewer paradigm shift, basically rethinking our theoretical assumptions in a very fundamental way, and less coalescence of theories and methods with other disciplines. So psychology, for example, is also only a century old, or a little more than a century old. And of course, you could think about more general theories that explain why certain psychological effects might be brought about by societal conditions, or how societal developments can be explained from individual psychology. But these types of coalescence have not taken place, at least on a massive scale. But that also means we have lots of opportunities to learn from example. So 2 ingredients for success in the natural sciences have been systematic observations and ideally experiments. And we are getting very good at recording systematic observations for social science. So you can choose between like 20 or 30 textbooks today that will explain to you exactly how you should do your historical research, your comparative qualitative research, or your quantitative research, and how to sort of select your evidence to test the observable implications of your theories. And of course, the other thing is, like, I wrote formal modeling. It should be more something like functional thinking, thinking between sort of the functional relationships in the properties that you observe. There are, of course, like basic fundamental obstacles in the way as well. Experiments are not always ethically possible in social science. So I study war. I cannot just trigger war under experimental conditions to sort of see what happens. And formal methods must take like non-uniform, maybe complex human behavior into account. So no offense to natural scientists, but if you study inanimate matter that always responds the very same way to an experimental treatment, you of course have faster development cycles of your theories, and you know faster whether or not there's something to your observable applications. So how can we arrive at explanations and predictions then in social science, given that you guys had a head start of 1,000 years or so? In the absence of real experiments, we analyze quasi-experiments to test our explanations, and we use the insight that we have and somewhat data-driven statistical techniques for predictions. And this is what many political scientists try to do with regard to civil conflicts. There's some in the audience who do that with regard to civil conflicts, and I'm just one of them. And one unfortunate side effect is that we might sometimes come across as cold-hearted technocrats in the process. That means any decent human being that looks at what's, for example, going on in Syria right now would tend to feel compassion. So sorry for the victims, sorry for the lives lost, sorry for the uprooted sort of, individuals and the material destruction. And at the same time, the conflict people talk about like standard errors and statistical models and get all nerdy about collecting the observations. But we're simply trying to be cool-headed scientists crafting badly needed explanations and predictions. So cool-headed instead of cold-hearted, because we really need these explanations. If you think about just the policy debate on, for example, how to contain the violence in Syria, the explanations are all over the place what's going on, and why it's going on, and what the counterfactual scenarios will be. And in order to contribute some evidence-driven insights, we need explanations and predictions. So this was the most general introduction that I could possibly come up with. And so then I decided on this slide to zoom a little bit into the area of my research. And for this purpose, I stole this slide from Uppsala University. They have this Uppsala conflict data program going on. And this is an enormously important research contribution. Because there are no official statistics that international political actors can agree on wars, for example. There's also no official definition of things like terrorism. And the simple reason for that is that if you have an officially agreed upon data set that says the US invaded Iraq in 2003, you might conclude that this corresponds or should be classified as a war of aggression, which might be illegal under international law. And so you could talk compensation. So this would be a very touchy political issue. And this is why we're on top of being sort of a young branch of science, or in the context of conflict research, also a data-deprived branch of science. But the courageous people at Uppsala and also at Rio and many other universities have started to put together an awesome data set, the armed conflict data set, that codes all wars going on in the post-World War II period. And this slide just shows you the different numbers of conflicts going on disaggregated by type. So extra-state, this is this gray thing here on the bottom, is essentially colonial wars that sort of have died out in the 1960s because the colonies all gained independence. You have interstate wars, which are on this long, steady decline, the yellow thing. And then you have internationalized conflicts, which are essentially civil wars that then pull in international actors. But the big red elephant in the room, of course, is civil conflict, the intra-state wars. And by any conceivable metric, numbers of casualties, material destruction, overall counts, civil wars are the big political violence problem of our time. And you can even make out somewhat general trends in this plot. So when the Cold War started to heat up after Korea, after the Soviet Union showed that it had the capability of launching a satellite into orbit, which by extension means that they could place nuclear warheads on any place on the planet they wanted, and the Cuban Missile Crisis hit. So here in the early 60s, you see this sort of steady increase of civil conflicts up to the end of the Cold War. And this, of course, has been subject to scholarly debate, and people have essentially concluded that this is because civil wars started at a faster rate than they ended. And the reason for this is that you could take your little guerrilla army and go to one of the superpowers and just pay a little lip service to them and say, well, we're all about freedom and democracy. Or you go to the other superpower and you say, we're all about socialism. And each of these little lip services would essentially finance your guerrilla campaign. Which means that you could keep it going sort of longer than you would be able to if you only had domestic resources. And then with the collapse of the Soviet Union, you had maybe a little peak here with the former Soviet satellites gaining independence, sometimes fighting for independence. You had Romania, Tajikistan, for example, and then the Chechen wars, of course. But the second striking feature of this plot is the decline after the end of the Cold War. And people were really happy about that and started to write papers about that and policy briefs, and essentially concluded that humankind was coming to its senses and would be more peaceful, which was good. Until the trend started to reverse a little bit, and now we're essentially where we used to be at the end of the Cold War. So with the Arab Spring having gone bad in so many places, was a raging civil war in Syria, Libya, of course the unresolved 9/11 conflicts, we are essentially in a situation where the future is very much uncertain. It could be that we see a global escalation again, or these wars could somehow resolve themselves. But we just don't know what's going to happen on this macro level.
Sorry, could you read the colors for us? We can't read them in the back here.
Okay, red is civil conflict, black is internationalized, yellow is interstate, so between states, and gray is colonial, anti-colonial. So yeah, I more or less said this. So some questions therefore spring to mind, and one of these questions is what keeps these conflicts going, and what causes civilians to support the military actors or even join the military actors, which is a process that we know exists in civil conflicts. And of course, could we have seen this coming, or could we have seen certain aspects of this coming? And in the following, I will give some examples of how I have approached such questions in my own research. And the first project sort of aimed at the explanation side of things, aimed at understanding how civilian loyalties are a function of violence between the military actors in civil wars. So scholars and practitioners agree that civilian loyalties play an important role in civil wars, particularly in insurgencies. And especially counterinsurgency theory assumes that violence drives these loyalties. So insurgencies are a particular kind, the most frequent kind of civil war, in which the rebels usually don't have a regular army. So for example, a counterexample would be Yugoslavia breaking apart. So suddenly you have different ethnicities that sort of inherit from the former state different branches of the military or heavy weapons from the military, and they start going at each other with these conventional weapons. In insurgencies, you have an irregular uprising with maybe in the beginning captured or improvised arms with sort of part-time combatants that might be like farmers during the day but turn into combatants at night. And they're a very sort of frequent phenomenon in the context of civil conflicts. And a lot of sort of theorizing and study has gone into understanding the processes in these conflicts. Counterinsurgency theory was sort of an attempt, initially an American attempt, to understand these conflicts better in the context of the Cold War. So communist uprisings in Vietnam, for example, but before that in Malaysia, sort of triggered the American, or caused the Americans to look deeper into this and develop counterinsurgency theory. But the way in which violence drives loyalties is contested. And there are essentially two general explanations out there that you don't find only historically, you also find them in the contemporary policy debate. And the first one is sort of deterrence-based. And these explanations assume that higher quantities of violence against the insurgent essentially weakens the insurgency. So you just need to use more violence to contain an insurgency. That's the premise here. And there's actually a little bit of theoretical underpinning for this. And the theoretical underpinning is that in social science, one of the sort of favorite theoretical paradigms for explaining outcomes of social movements is collective action and the collective action problem. And the collective action problem essentially just says, if you're a rational individual and you take part in some group exercise, and the end result of the group exercise is going to be something that's available to everybody, like a revolution, then the best thing you can do is do nothing. And let all the others do the work, let all the others take the risks. So if you even increase the risks, if you even increase the risk of participating in this exercise by an increased application of violence, you should sort of harden the collective action problem for the insurgents, and everybody should decide to stay home and not take part in the insurgency. So the expectation is that one applies more violence, fewer individuals will work as the adversary, versus the insurgent. And there are Vietnam-era examples. So then Secretary of Defense Robert McNamara had this awesome idea for how to measure progress in Vietnam, and it was the body count indicator. So how many enemy combatants are reported killed? And if that number, he assumed, hits a certain ceiling, then we're going to win the war. And Kissinger, who for no good reason whatsoever even received the Nobel Peace Prize, can be famously quoted as saying that he doesn't believe that a third-class power such as Vietnam does not have a breaking point. And it's really this hawkish rhetoric that you can find not only in American foreign politics, but like as a very standard go-to assumption of how you can contain an insurgency or an uprising. And of course the contemporary example would be Bashar al-Assad in Syria, who looked at what was happening to his buddy Gaddafi in Libya, what was happening in Egypt, and then he saw a protest movement and he said, we better not let this get out of control. We better use an iron fist to contain it. So there's a second set of explanations out there, and these are alienation-based. And they assume that only selective violence against the insurgents, so only like fighting the actual combatants, weakens the insurgency, while indiscriminate violence that also affects civilian bystanders strengthens the insurgency by essentially solving the collective action problem. And this sounds a little bit counterintuitive because we just used the collective action problem to sort of argue for the opposite, but the literature on collective action tells us that there's one remedy for the collective action problem, one thing that will make it go away, and these are selective incentives. So if you're personally, individually motivated to do something that happens to be the same as the group exercise, and if everybody has such a private incentive to participate, then of course you don't have a collective action problem. And the idea is that if you use violence indiscriminately and you kill innocent bystanders and civilians and you destroy property, then more and more individuals will be motivated to take revenge. And this will be a personal selective incentive to them. And that would mean that if one applies more indiscriminate violence, more individuals will work with the adversary. And again, we find Vietnam-era examples. The counterinsurgency theorists, the American counterinsurgency theorists, essentially pushed for such thinking. And you have contemporary examples in terms of David Petraeus and Stanley McChrystal, who have sort of extended counterinsurgency theory and tried to apply it to Iraq and Afghanistan. So conflict research has looked at this, of course, and has somewhat produced mixed empirical insights. And I would argue that we see these mixed results for two reasons. And first, we see them for conceptual reasons, and that is sort of those approaches to deterrence and alienation sort of assume that sides are taken in response to violence. But for civilians, taking sides openly in civil war is extremely dangerous, right? The moment you start waving the flag for one side, you will be in the crosshairs of the other side. And that means civilian reactions to violence should be concealed. They should be not publicly visible, and they might occur at considerable spatial and temporal distances from the trigger event. Maybe I'm inclined to sort of avenge my fallen loved ones at a certain point in time, but it might take me 2 or 3 weeks before I find an opportunity to do so. And there are also empirical reasons for these mixed results, I believe. So studies usually focus on responses within arbitrary spatial and temporal units, and if there's no empirical or theoretical reason to look at administrative units or grid cells or whatsoever, you might get all kinds of empirical results. And a sole focus on reactions to violence might be missing the point. Maybe there's something else going on than just sort of the exposure to violence. And of course, future violence can also be caused by past violence. So if you want to look at this in this sort of quasi-experimental causal setup, you cannot just explain violence to violence, because you might be mixing up cause and effect all over the place. So inductive techniques would be needed to account for the spatial scales of the reactive effects, and for the causal analysis, we need to focus on civilian behavior that does not affect future violence. And in collaboration with Carsten Donai, he was also at ETH at the time, he's now in Geneva, I've put together a method that does that, and this is essentially a short rundown of how it works. And the idea is that you have events, you have event data, so incidents reports of something might have happened somewhere, and these little stars could be like instances of civilian assistance to US forces in, say, Afghanistan. And we know the latitude and the longitude, so we know the spatial coordinates where this happened, and we also know when it happened, because we have a date information for these data points. Now we also have instances of selective and indiscriminate violence. The little triangles could be selective, the little rectangles could be indiscriminate, for example. And one simple thing you can do for statistical analysis is to just say, we're going to define a certain temporal distance and a certain spatial distance. And for this temporal and spatial distance, we're just going to count how many instances of civilian assistance we see before and after selective and indiscriminate violence. Once you've done that, you can sort of even subdivide this lower half of this cylinder and find a trend in the preceding instances of civilian assistance and count the posterior activity. And because it's geographic data, you can also superimpose it on spatial covariates. For example, what is the predominant ethnic group in the region? Is this a rather accessible spot or not? How far is this from Pakistan? Because maybe there's Pakistani combatants crossing the border. Just as an example. And what you do then is you apply this sort of quasi-experimental logic to this. And the idea is that there might be instances of indiscriminate violence in the data with certain characteristics. They have a certain trend preceding it, they have these spatial attributes. And now you're not going to allow all the instances of selective violence that you find in the data to be part of your statistical sample. But what you do instead is you only include one that is most comparable to the indiscriminate violence incidents with regard to these preceding trends, preceding counts, and spatial covariates. And the only difference essentially is that one is indiscriminate and one is selective. And if that's the only difference, then that is the thing that we can also attribute the change in support to. So we try to isolate the causal effect of selective and indiscriminate violence. And this is modeled in this difference in differences regression setup. If you have questions about this, I'm happy to talk about this too in the Q&A. But otherwise, I would just go on and essentially talk a little bit about the problems with the setup, because it doesn't like function perfectly. So, I mean, maybe if you go back one step, you can really see how this translates. I mean, here we have this binary treatment indicator, either it's selective or indiscriminate. Here you have the previous violence, and here you have the posterior violence. And in this regression setup, you would essentially say, let's estimate or let's predict the posterior violence, so the thing in the upper half of the cylinder here, as a function of the previous violence, the binary treatment, and some error term. And that's essentially your way to arrive at this posterior count. And of course, the weights here for these different variables is sort of they're derived from the data and chosen in a way to like optimally predict these posterior counts. So this setup doesn't like function perfectly all by itself, unfortunately, because we're not in an experimental domain. There are two problems here. The first problem is that we don't know which cell sizes to choose, right? And the solution to this is we repeat the whole analysis for multiple cylinder sizes. That will give us a sense of how robust the results are to changes in these cylinder sizes. And the other problem is the so-called stable unit treatment assumption, and that is just a very intuitive demand that you have on your real experimental setup. In a real experimental setup, where you, for example, test the effects of a drug on patients that have a certain disease, you want to give placebos to some, and you want to give like treatment pills to others, but you don't want them to start like eating 2 placebos or 3 treatment pills and trading them back and forth or splitting them up or something. You don't want that. And of course, this is exactly what's happening when the cylinders overlap. It's like, then you're not looking at the effects of indiscriminate violence, but you're looking at, for example, the effects of indiscriminate violence that have been preceded by selective violence right before it. So that would be a violation of the stable unit treatment assumption. And the solution to this is to apply this matching procedure, so this selection procedure that I just talked about for the observations, to previous control and treatment event counts. So sort of make this a matching variable too. And we've looked at this in simulations, and it actually works. And the reason that it works is that if you're comparing your indiscriminate violence sort of observation with a selective violence observation that has been preceded by an indiscriminate violence observation, you're comparing apples and oranges. And now you're building a sample that has apples and apples, oranges and oranges, and maybe, I don't know, melons and melons. So it is contaminated in the sense that the stable unit treatment assumption is violated, but at least these violations are sort of consistent for the treatment and the control events that you're including in the sample. You need a lot of high quality data for the setup, and I use the significant activity files from Afghanistan that distinguish among 160 event categories and amount to 75,000 observations for the time period 2004 to 2010. This data has been made available to the general public through WikiLeaks in 2010. And it can be geographically joined with information on ethnicity, wealth, terrain, and other sort of context factors. The problem that SIGAC has is that it has been coded by the US ground forces. And that means the civilian-insurgent interactions are not recorded. But what we can do is to look at, for example, reported indiscriminate insurgent attacks that probably affected civilians and how that affects the civilian-US ground force relations. And we can do it the other way around as well. So we can sort of focus on this link in order to test the theoretical expectations. And I had to code, of course, selective and indiscriminate violence, and I essentially decided that the best proxies for this that I could find in the data set were direct and indirect fire. So intuitively speaking, the difference between using small arms in direct fire encounters and heavy arms, like artilleries or tanks or airstrikes, that would probably cause more indiscriminate destruction and could affect innocent bystanders. And I did this for the insurgent side and for the incumbent side, one time focusing on close air support and for the insurgents on mine strike. But it's really mainly the difference between direct fire and indirect fire that does the heavy lifting empirically. And I measured the civilian collaboration with the incumbent in terms of the numbers of improvised explosive devices and unexploded ordnance that are turned in. Why would that be the right proxy for civilian collaboration with US ground forces? The reason is that, as you can see on this picture, unexploded ordnance is very frequently turned into improvised explosive devices. And these improvised explosive devices are the most lethal and most effective weapon that insurgents have in Afghanistan. They cause the most US casualties. And when civilians, that was the reasoning, find an unexploded artillery shell, they essentially have the very rare opportunity to take sides in civil war without using violence and without flagging their loyalties publicly. So they can secretly walk up to the US ground forces and be like, hey, I found this artillery shell. We need a demolition team over here. Or they can go to the insurgents and say, this might make a nice improvised explosive device. Or they can do nothing. But the important thing is really that they don't have to signal their loyalties publicly. And this is what the results look like. So let me explain this a little bit. So we have different cylinder sizes for the spatial offset from the trigger event. We have different temporal distances, or temporal sizes of these cylinders essentially. And here, with the legend on the right, we have the estimated quote-unquote treatment effect. The estimated effect on of indiscriminate violence on civilian collaboration. And the crossed out areas are called statistically not significant, which means unreliable correlation. Just think unreliable correlation. But the non-shaded areas are somewhat reliable correlations by the industry standards of the discipline. And they are interpretable. And that, in the case of incumbent violence, we see that if US ground forces use indiscriminate violence, and we look at it at like larger spatial and temporal offsets, we see that fewer instances of civilian collaboration occur. So more heavy arms, fewer collaboration. For the insurgent side, we see the opposite effect. More insurgent indiscriminate violence, more collaboration. And this, of course, shows a weak but probably important effect, and that is civilians tend to collaborate more with the enemy of the perpetrator after heavy arms are used. And it supports the alienation story and suggests that hawkish rhetoric might sometimes backfire. So if you hear somebody talk about like an irregular civil war and that somebody's resistance needs to be broken and it's time to use an iron fist, this might blow up in their faces. And of course, this insight can be criticized from all kinds of angles. It's only Afghanistan, with specific design choices in the operationalization. But I think it is supporting evidence for the alienation story that is also a prominent story, like from qualitative and anecdotal insights. Of course, the data does not yield nicely separated network experiments, but clustered events that are harder to analyze in a causal inference framework. That is, a certain amount, like 40%, 30 to 50%, depending on where you look at it in the plot, are these clustered events. So this is a problem, but we're a non-experimental discipline. So the other example for looking at the explanation side of things is collaborative work with Rose here, who's sitting over there. And the goal was to get time-variant individual level data on experiences and hostilities in civil war. So essentially, and a little bit of an extension to this, because the analysis that I've just shown you now looks at observational data and actual events. But of course, if these alienation stories hold or these deterrence stories hold, you would see that civilian sentiments essentially change and their assessment of the situation. And maybe this alienation effect even scales beyond the perpetrator of indiscriminate violence. Maybe this scales to the group level, that over time the sort of attacking side is associated with an ethnic group, for example, like it might now be the case with Sunni and Shia Muslims in Iraq and in Syria and, frankly speaking, throughout the Middle East. In order to get to these effects, we need better data. So the way to do this is to run surveys, but surveys have their own set of problems. If you conduct them face-to-face, they're costly and dangerous to implement, dangerous in the context of civil war research. If you do web-based surveys, they're often focused on what's called the weird population, that's Western, educated, industrialized, rich, and democratic. That's not your civil war material. There is some research on SMS-based surveys that sort of suffer from very low response rates. But they offer a lot of potential beyond that. And the innovation in this research project was to combine SMS surveys with a mobile payment system called M-Pesa. So M-Pesa was this initially Kenyan and Ugandan bottom-up innovation. People had a function on their mobile phones that allowed them to transfer prepaid credit to another phone. They could hack in a number code, to this number I want to, send 50 US cents or something, and they started paying for groceries in the market with prepaid credit, which might not make too much sense for us, but these are countries with huge unbanked populations where everything is done in cash. So having an electronic currency on your hands is a huge boost to your ability to do business, essentially. And so the Vodafone company essentially at some point jumped on this and said, hey, this is awesome, let's turn this into a banking system. And they rolled it out in 10 countries in South Asia and Sub-Saharan Africa. And so we implemented this in a new computer system for reimbursed mobile surveys, or RMS, that has the following features. So first of all, it's really, really cheap, the system, which is kind of awesome. And then the surveys are automated in software, so you don't have to send SMS by hand and ask people, did you get my last SMS, and do you want to answer to this? And it hopefully produces high response rates. We have preliminary insights here. Happy to talk more about this in the Q&A. And it does not require physical presence of the researchers. And it can reach response anywhere in a given country, but we can also have geographically targeted surveys with this. And we can have panel surveys, that just means surveys over time with the same respondents. And here's sort of a schematic setup. We have a database server in Konstanz and a survey computer in the countries we're interested in. And the survey computer builds this sort of encrypted, secured data connection, gets a new number from the database server for a respondent that is then invited via SMS. Do you want to participate in the survey? And upon an affirmative response, if we get anything else than an affirmative response, we never ever contact them again. But if we get an affirmative response, we reimburse them for this response and ask the first question and repeat this exercise until the survey is done. And it's affordable because we use this literally 35 euro computer and this 15 euro GSM modem, and put it together with a little touchscreen, and this is the computer that is on its way to Afghanistan now. So the system has been used for a proof of principle application in India. Based on a trial with over 1,000 participants, we have established that reimbursed surveys produce higher response rates. We also bumped into major regulatory issues in India that are to some extent still unresolved. But I'm very, very optimistic that we'll get it to work, and that we will be able to conduct reimbursed surveys to find respondents for several survey rounds, and then measure the selection effects. Because the big problem is, of course, we're not going to get a representative sample of the Indian population with this. Maybe young people will be overrepresented, maybe lower income strata will rely on this banking solution more than higher income strata. And we need to sort of measure these attributes, demographic and financial attributes of our target group, of our respondent group, and then compare this to a 2011 census that we have available at the same geographic resolution. And of course, the system is being deployed to Afghanistan and will be deployed to Kenya as well. So I have like 2 more examples from my research that look a little bit more at the prediction side of things. So the ISIL advances in northern Iraq and Syria have largely taken the international community by surprise. And in June 2014, ISIL captured 7 major cities in Iraq, and you're all aware of the disastrous humanitarian consequences. And the question that sort of springs to mind here is, could one have anticipated increased violence in these regions? Or more generally speaking, can we come up with an informed guess of where violence is going to strike in a civil war environment, where we see the highest levels of violence? And again, I focus on insurgencies here because they have this sort of distinct spatial and temporal footprint, and they have a lot of theory behind them. So essentially, during the Cold War, insurgencies were being sort of actively promoted and developed as a means of socialist revolution. So Mao Zedong, Ho Chi Minh, Che Guevara, they looked at insurgencies and said, this is the way we can craft revolutions out of limited material means, essentially. And if you look at the sort of standard Mao recipe for successful insurgency, you find that the rebels challenge the state from the remote periphery, recruit new combatants from the local population, and only sporadically engage in hit-and-run attacks. They essentially try to evade the state wherever possible, try to stay alive, try to attract new combatants. And then they slowly expand their areas of control and finally beat the regular army in the field and capture the capital city, and then they're done. So we also know a little bit about what the actors are fighting over. We know that they're sort of trying to win civilian loyalties, that they're winning hearts and minds. They, of course, need strategic resources such as oil, diamond mines, and so on. And we know that the rebels start out many of these insurgency campaigns in the remote periphery, while the government sort of protects the center. And that means that we can sort of look at a number of variables, a number of possible correlates of conflict zones. In terms of population centers, where do we see the highest number of concentrations of population? Because these are the areas that you might want to control in a population-centric war. The capital and border distances for any given spot you might be looking at. The spatial distribution of wealth, is this sort of a target where it might be easier to recruit new combatants because they feel like economically disenfranchised and sort of support the revolution. Travel times to major cities is one way of like measuring remoteness. So this is an interesting data set that sort of superimposes roads and railroads, natural obstacles, and all of these things, and calculate for any given spot how long would it take me to reach the next city of 50,000 or more people. And if that takes you a really long time, that's because you're in the boonies, of course, somewhere in the country. And natural land cover might also mean that in the initial stages of the insurgency, it might be easier to sort of evade the state's reach. And I looked at a data set from Lyle and Wilson that sort of codes which insurgencies have taken place around the globe. And then another database, again, from the UCDP data program that looks at individual events that happened, very much like the WikiLeaks style data, for the corresponding time frame. So I joined them just by looking at the duration of the war in the country and then which incidents happened there or can be found that correspond to that in the UCDP GED data collection. And the general setup here was to fit point process models to data So these point process models are like the regression model that I've just shown you, with a little twist. And the twist is that, first of all, you know that you know a little bit more, or assume a little bit more about the sort of distribution of your dependent variable. It's a count-dependent variable, right? You want to predict the number of points that you see in any given region. And then it also comes up with this sort of data-driven way of essentially chopping up the geographic region you're looking at according to the point pattern. So you identify the region in which the values of the geographic coordinates might make sense based on the point pattern. And then once these models are fitted, you can of course simulate point patterns from the models. You can just say, okay, predict for these geographic covariates, what is my point pattern going to be like? And then you calculate an error score based on the difference between the empirical and simulated patterns. That was the entire idea. And this is what this looks like. So here we have the UCP GED data from the Second Liberian Civil War. And you see the events sort of cluster here a little bit in the periphery, and then in Monrovia, so the capital city region. And you can sort of smooth this out, sort of turn this into a high resolution histogram, and represent it as this sort of smoothed out surface. And of course you can do the same thing with a simulated point pattern. And if you just look at the point patterns, they're not quite the same thing, but they bear some similarity to one another. And so do these like smoothed out surfaces. And the prediction error score that I used here was just sort of the integral here between like the empirical distribution and the simulated distribution. Of course, it's just a numerical approximation of that. Now, the interesting thing is that this sort of gives you a very straightforward idea of how good you are at predicting. And the way to do that is you build a baseline model that is just random. So you take 100 points, for example, because you have 100 points in the empirical sample, and then you distribute them at random, and then you calculate your error score, and you do that a bunch of times to calculate an average error score and normalize this. Just say, okay, my average error score is here, whatever, 3.62, whatever that's supposed to mean. But I'm just going to say it's 1. I'm normalizing it to 1. And when you run the same exercise, like predicting lots of point patterns from a simple model that only knows about the population, you only arrive at 0.47 of this error score for the random model. You're 50% better than the random model. If you include capital distances, it goes down to 0.28 and 0.24 for population, capital city, and accessibility, and so on. So you get an overview of how good you are in comparison to a complete random baseline, a complete uninformed guess. You can do this out of sample, and it essentially gives you the same magnitude of like error scores for your empirical models. But this is just a number, so maybe that's not that persuasive. You can of course also look at the predictions, qualitatively speaking. And on the left-hand side, we see the empirical pattern. In the middle, we see the in-sample prediction, and the really interesting thing is the out-of-sample predictions on the right. So how did I arrive at these out-of-sample predictions? I have my 10 countries, and now I'm pretending that I don't know about Algeria, for example. And I fit my models on 9 countries, and then take that fitted model and apply it to Algeria. I sort of emulate a situation where I don't know whether the next conflict is going to take place, but I have already a bunch of insights from other countries, and then I'm predicting beyond the sample. And you can see that, like, qualitatively speaking, in Algeria and Burundi, these conflict zones are more or less predicted where they are actually observed, even out of sample. And in Chad and in Congo, we see that, first in Chad, we see that this prediction also kind of holds up. We have this little secondary concentration of points here that is a little bit exaggerated in the prediction, but it more or less looks okay. And in Congo here we see that we have a complete misprediction. So it's not at all where it's supposed to be. And if we look at the Democratic Republic of the Congo, it's sort of a mixed bag. The capital, the Kinshasa region sees a little bit of violence, but we also have this like notoriously violent, notoriously unstable Eastern Democratic Republic of the Congo, which is essentially completely missed in the out-of-center predictions. And Ivory Coast, again, doesn't correspond well qualitatively, just eyeballing it essentially to the empirical observations. But Guinea-Bissau and Liberia look a little bit more like the real thing again. Oh, and we have Rwanda and Sierra Leone, which also sort of show the conflict zones, or the two conflict zones more or less, where they were observed. So that sort of means that reliable spatial patterns exist for some forms of political violence. And in the long run, a framework for assessing risk areas could be used for policy advice and humanitarian relief operations. But the presented results, of course, don't allow for clean theoretical inference, so we cannot talk about like testing mechanisms with this setup in any way. And the approach is completely agnostic to history and geopolitics. So this is why prediction and explanation might be different things in our discipline. Oh yeah, what happened to ISIL? So if you apply this to Iraq and Syria, so first of all you have the problem that this modeling setup assumes that there's essentially a closed polity. There's no such thing as ISIL tearing down the border between Iraq and Syria and establishing like something here in the middle. And for Syria, we see that these like escalations here in the eastern part of the country, where the Kurdish minority lives, are not predicted correctly. But it is important to keep in mind that Syria has more than one civil war going on. And the sort of uprising against Bashar al-Assad really took a toll in terms of civilian casualties and material destruction here in this coastal region. So that is certainly, if you look at all the conflicts that are going on in Syria, a valid sort of prediction of a high-risk area. And in Iraq, of course, we have more than one civil war going on again. If you look at the WikiLeaks data for Iraq, it's essentially all clustered in Baghdad. This is where 90% or 80% of the conflict is playing out. And this northern part of the country has not been affected as much. But now, of course, Mosul is the de facto capital of the Islamic State. So again, if you're allowed to pick and choose between the 4 conflicts in 2 countries that are going on, you find that these are valid risk predictions, but the situation is just so messy that this prediction might not buy as much for these 2 countries. But it was a motivating example, so I kind of honed you this figure. Okay, I'm almost done. I'm just going to rush through this real quick. So there's ongoing collaborative work with Niels Weidmann, and the idea was to sort of measure the intensity of violence in civil wars, which we can only do through media reports right now, which is really, really bad. Because media certainly underreports violence in the most dangerous areas. So who is going to go to the ISIL-controlled areas to keep track of what's going on there? So monitoring escalations of violence in real time is almost impossible. And we need better ways to get information from active conflict zones. And the idea, sorry, this is rather dark, the idea to do this is to utilize remote sensing. And we're not the first people who have used remote sensing for conflict research related activities, but we're looking at nightlight emissions that you can see here, probably not, but this is the Arabian Peninsula, and you can see that sort of the Emiratis have like lit up their little highways during the night, and you can see that everybody lives by the Nile in Egypt. So we have these nightlight data, and we have very good ground truth data for Iraq, which is also somewhat rare. So WikiLeaks published something short of 400,000 incident reports coded by the US military between 2004 and 2009. For these incidents, approximate location, types of incident, casualties are known, and the investigative project Iraq Body Count also utilized WikiLeaks data as well as media reports to build a comprehensive data collection of the lost lives in Iraq. Actually, we probably will end up using this Iraq body count data for this research project. And then there is the Defense Meteorological Satellite Program Operational Line Scan System that measures nightlight emissions globally. And the data are available for download in monthly and in yearly aggregates as well. The yearly aggregates have a number of advantages because I don't want to work with raw satellite data. You need a geospatial specialist to do that. There's, for example, things like gas flaring. If you look at like sites of oil extraction or something like that. These are stationary lights that you might want to exclude from your statistical analysis, but I wouldn't be able to find them. Wouldn't be able to find them. And for these yearly aggregates, you have NASA specialists looking over this and only sort of keeping the variant light sources in the data while removing the stationary ones. And the expectation, of course, is as nightlight emissions should decline as violence increases, because people might turn into refugees or their homes might be physically destroyed. And this could give us a lot of leverage about seeing more or less in real time, if we switch over to the monthly data at some point, where violence is happening, where war is escalating. So if you look at this on the country level, this is just still the WikiLeaks data. This is normalized to 1. All the casualties per year that you've seen in the WikiLeaks data between 2004 and 2009. And as you can see, it starts out with this sort of anti-US occupation insurgency, but then massively escalates in 2006 and 2007 as the conflict takes a sectarian turn. So these mosque bombings for Shia and Sunni mosques kick in, and the conflict really takes an ethnic or sectarian turn. So if you superimpose that with the nightlight emissions for all of Iraq, you see this like very strongly negatively correlated graph over here. So the nightlights actually do take a dip here as the violence increases. But this is only the whole country. This is not city level. This is not like geographically disaggregated in any way. And as a first analysis, looked at 21 major cities in Iraq with more than 10,000 inhabitants, the corresponding years, and correlate the annual change in nightlight with the change in sort of reported casualties in that location. And you will never ever see this figure anywhere again because it's all very preliminary. But you sort of see in this very simple sort of correlation exercise that if you have sort of positive changes in nightlight, even if places come back, you see that violence sort of declines or is on the decline. And if you see negative changes in nightlight, you see positive changes in casualties. But this is a very preliminary analysis, and for example, we've just chosen a random, more or less arbitrary buffer around these cities, and one would have to talk about more which cities to look at, and sort of a data-driven way to select the places you want to investigate. So this is very, very preliminary. But this is the end of my presentation. Big thanks to the Zukunftskolleg for giving me the opportunity to pursue this research, and especially to the always friendly, always helpful back office. Thank you.
So now the back office takes over and discussions. So I look forward to receive your questions. So good. So we start with Antonio.
Thank you, Sebastian. Great talk. That was very exciting, very interesting. I have just a question that may sound naive, but what is your definition of conflict? And is there a coincidence on all scholars on what is the definition of conflict?
Yeah, I was shortening the talk yesterday because I had way too many slides, and the definition slide is among the casualties of this shortening process. I'm sorry about that. So the Civil War definition is that you're looking at violence between organized groups within the same state or territory. And that's sort of the most general definition. And by extension, that means that one of these groups is usually the government, right? The government that sort of is usually has a monopoly on violence and then sort of fights the challenger of this authority. But of course, this is just a very theoretical idea. The problem that we have is what qualifies as a civil war in the data. Mm-hmm. And there are essentially two thresholds that are frequently used. The older one comes from a different data project, the Correlates of War project that was started in the 80s, that looks at conflicts that produce more than 1,000 casualties a year. So these are sort of high intensity conflicts. And the UCDP data that I showed in the beginning of this plot is like 25 battle death. So in a civil conflict, a lot of people can die from the secondary consequences of the war because, you know, the economy goes down and, you know, medical supplies might not be available and things like that. But the data definition requires 25 people to die in actual combat to qualify as a civil conflict, and at least five from either side. Because there are also incidents, of course, of one-sided violence, genocidal violence, for example, where no perpetrator dies, and we don't want to qualify that as a civil war.
Alexandra?
Thank you for the talk. It was really interesting. And I have a question about these examples which you showed. Have you checked which variables make the most influence on your models for each of the country? Because intuitively I could assume that, for example, in some countries the place where a capital is the most influence part for the conflict, or in others it's the geographic landscape or anything.
Yeah, you're totally right with that expectation. So first of all, the models perform very differently for different countries, and so the idea, so it was sort of this twofold. Or there were two objectives with this paper. The first objective was to find some variables that actually do some heavy lifting in the predictions, but more importantly, I wanted to put together a little framework that would allow people to sort of plug in different variables in functional forms, and then try to see which of them work best in general. So running different models for different countries would also be possible, but of course, the really useful deliverable would be to say, here we have identified a number of variables that will help us sort of predict the future or see where future conflict zones might emerge. Yeah, but I haven't used this framework myself so much to find like the best predictors. I think in these models it's like population for sure. Population concentration is the biggest predictor, which might or might not be big news, because on the one hand it corresponds to the fighting over civilian loyalty story. On the other hand, we also have a media reporting bias, right? If a place is more inhabited by more people, chances are the news will also make it to the international headlines.
I also have a nice proposal for the one of the country which you can also place this data. Mm-hmm. So in Ukraine, it's not so dangerous. It's available, and it's easy to get some surveys or anything.
That's true. So yeah. So I think for this project here at the Zukunftskolleg, what I would really like to do with sort of the remaining time of the fellowship would be to understand a little bit better how like individual level hostilities really play out in these conflicts. Because there's on the one hand a huge scholarly debate about that, and on the other hand this would also sort of translate into actionable knowledge at some point of how to contain hostilities. And I hope to be able to get that through these like SMS interviews, for example.
Great, Violet.
Okay, two questions. One question is that, as far as I understood, the model somehow assumed that the population is somehow homogeneous, but from the other side, we know that there are lots of conflicts, not most of part of conflicts, actually based on some kind of ethno-religious wars. Mm-hmm. So, and you cannot just predict this by geography without ethno-religious distribution data. The second question is about asking about two models, indiscriminate violence and selective violence. And then the question is that the both models are somehow expected that our dependencies are monotonic. But if we are trying to think about that, if we are trying to, for example, if the level of violence is quite low, then there are these collective action agreements. But from the other side, on the very high level of violence, there can be a situation that the one of the part of the conflict cannot like recruit enough people just by demographic means, like the right things or something. So that's potential.
Yeah, so for the reactive study in Afghanistan, I've taken ethnicity into account by sort of coding the predominant ethnic group in the regions. For example, we know that the Taliban recruit among Pashtun youth, and so they might actually be sort of a priori adversaries of the US ground force. You might observe like lower levels of support there. But this is sort of one of the possible confoundings that I've taken into account for this study. For the conflict zone prediction, of course you're perfectly right. Ideally you want to know which ethnic group with which allegiances is where to be found and how that could translate into a conflict scenario. This information just doesn't exist sort of on a global level. You wouldn't know what the allegiances of these ethnic groups are in conflict situations. And with regard to the sort of inability to recruit from or recruit at all in high intensity conflict zones, I think you're perfectly right. There are a number of intervening factors that could come into play here. For example, the most obvious one is that even if you want to support the US ground forces, you might not have an artillery shell in your yard. So this is why these effects that I'm reporting here that I found are comparatively small, right? There is still a lot of noise in the analysis and in the data, but I think it is good enough to be substantively interpretable.
Yeah, thank you for a brilliant talk. First of all, I really would like to sit down and let you explain me more about the cylindrical model stuff, because I think that would be awesome for many of my things which have nothing to do with conflict. But I was wondering, so in these models you show like the trigger event, and I'm wondering now, so when you have areas like Syria right now where there's really a lot of things going on, also in sometimes very small regional areas, how do you define the trigger event? I mean, because it might be a little bit problematic sometimes to really pinpoint like the one thing, or maybe it's a trigger event, not something like a specific event in time. Is this something more? Could it be also like a series of events, or how do you do this?
So the event comes from just the data, the WikiLeaks data essentially, that says at this point in time, in exactly this geographic location, artillery shelling of the village took place, and then they sometimes have a little narrative even associated to the event that is extremely difficult to read because people just don't bother to be very clear under combat conditions, and military folks are also really bad with like using acronyms that no academic has ever heard of, so it's like a series of acronyms that probably translate into some information that is extremely difficult to extract from these short summaries. So the event data is there, and where and when something happens is actually a sort of clear part of this analysis because it directly comes from recordings. There is, of course, a valid concern here when it comes to reporting biases. So the US ground forces, they know if something happened to them. But maybe they are inclined to sort of miscode certain information. For example, if you code, we decided to use an artillery strike against this village, it could be that you have to justify that tactical decision, especially after like McChrystal and Petraeus took over in Afghanistan, because things like courageous restraint, so not shooting back and not killing innocent bystanders, became a tactical objective. So the easiest thing you could do is say, well, we first received small arms fire and then we shot back, because then you're not going to have a meeting with your superior. And that's a valid concern there. And when it comes to this corresponding empirical analysis, so we put an R package online, and so people can actually do this analysis with whatever data they please themselves.
I have a question also about the combat zones. I mean, I'm all in favor of coming up with quantitative predictive models. On the other hand, I'm wondering whether the baseline you're comparing it to is a little bit unfair. I mean, a random distribution in a country like Saudi Arabia, I mean, nobody would expect events to occur randomly in the middle of the desert or at Riyadh or whatever. So, is there a way how you could kind of systematically integrate the best guesses that country experts would have?
That would be.
I don't know how to do it, but it would be something that would be, I think, a fairer comparison where the Curie model is on equal footing or maybe even better in predicting violence than self-proclaimed experts on the country could.
Well, no, that would be a fascinating follow-up for this, I think. That would be really interesting. Yeah. I don't know.
Prior based on qualitative stuff.
I mean, totally. If we should do it, if we can find the time. It's a good idea.
I found this reimbursable with mobile survey quite interesting. Have you considered any topics or applications where it could be used here or what it's in Western countries?
We don't have the M-Pesa payment system here. So that's the big,
technological barrier.
Yeah, it's a technological barrier, and we looked a little bit at like alternative electronic currencies that might come into mind. Like, for example, Bitcoin has been a thing for a while, but it's like a really marginal phenomenon of some computer geeks who like to play electronic currency with that. And it would be a game changer, though. To be fair, there are actually services out there that let you send Bitcoin via SMS. So the idea is to deposit your Bitcoin on some server, and they keep essentially track of your balance, and all the communication and the transactions done via SMS. So that would be a game changer and would mean that this could be applied globally. But I think for now we're stuck with the M-Pesa countries. And maybe a couple of years down the line, this could be rolled out in different formats with different communication technology, different payment technology. But the logic would stay the same, more or less.
Maybe data volume would be the currency. Interesting.
Yeah, I don't know. Yeah, it remains to be seen which of these technologies will emerge.
Ben?
In fact, my main question was pretty much asked. So my secondary point, which is more of a comment, is with people being so horribly complicated and all of human history in the past, how can you ever know you've got the right variables?
It's a good question.
I mean, you justify them very nicely, I should say, as well, but in general.
That's a good question. So, so it could be that we will never be able to find them, and it could also be that humans are so insanely complicated that their behavior is essentially more or less unpredictable. But I don't think that's the case, and the reason I don't think that is that there's this sort of figure of speech that history keeps repeating itself. I think the person who put this most eloquently is Mark Twain, who said, history doesn't repeat itself, but it rhymes. So we might have had a conflict between Russia and Great Britain in the 1900s, in the 19th century, so the Great Game, who's gonna dominate South Asia. Then we had run-ins between Western Europe and Russia in World War I. In World War II, during the Cold War, and now everybody's looking at Ukraine and it's here we have the new Cold War. So there might be more information in history and more sort of repetitive patterns that we can extract than we sometimes believe. Because when it comes to life and death, humans might not be as random as they are in their choices of music or their use of leisure time or something. But that's yet to be seen.
You want? Yeah.
Afterwards.
I mean, first question about this question is that you send by SMS.
Mm-hmm.
I mean, you send them in different countries of the world. Are they translated in mother tongue?
Yeah.
do you take into account the cultural differences that, I mean, different meanings of violence are lie in different cultures? I mean,
you're right, absolutely. So Rose and I have teamed up with Niranjan Sahu, who's an Indian colleague who works at the Observer Research Foundation in Delhi. And of course, the idea would be that we could produce a survey. Rose has quite a lot of experience in survey research, and then we would run the survey by him and not only ask for the translation, but also ask, are we tearing down any cultural barriers here, or is it the right way of putting the question? And for Kenya, it's the same situation with a country expert, and the situation in Afghanistan is also the same. So it's like people doing the survey side of things and the technology side of things, but then at least one country expert who sort of helps framing the thing. And I should also say that we're looking to doing like non-invasive survey questions, essentially trying to tease out like group allegiances and sentiments in a direct way. We wouldn't want people to say, I don't know, I hate the Taliban in Afghanistan or something like that, because it could have negative repercussions for them. Instead, we would go a more indirect route than questioning.
You showed this diagram with the nightlight and the violence rate. Are you claiming that there's a causative relationship?
No.
Okay, because
I mean, in one direction. I mean, if people go away, they don't switch on their lights.
That's true. I find it interesting, it's possible of course, but here in the Western countries we usually have the opposite effect, that whatever city planning considers illumination, setting this up, to be a factor to decrease violence and criminal.
But it would be the same here. I mean, if we have more illumination in place, the correlation shows that violence goes down, right?
But it goes both ways with the causation, probably.
I don't know. I mean, the way, I don't know. I mean, if you have really a civil war going on, just putting more street lights up is not going to decrease violence. We don't know. There is a lot of research out there that looks at, for example, the impact of communication technology. So what happens if you hook up a region to the mobile phone network? Do we see effects on violence from that? So I wouldn't completely dismiss this out of hand, but I thought about this the other way around. I thought about like material destruction and migration leading to decreasing illumination.
So there are no further questions as far as I can see. So I would like to thank once again Sebastian, a cold-minded scientist who helps making the world a better place.